This is Josh White with JW Math Tutoring. In this video, I'm going to cover Bluebook Practice Test 7 Math Module 2B, the harder of the 2-second math modules. So let's go ahead and get started.
But life is a dream that calculus could never predict.
Just before I begin going through Digital Practice Test 7 on the Bluebook app, the Math Section Module 2B, the harder of the 2-second modules. Just a couple things to keep in mind. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, you have any questions or comments or alternate solution methods, please feel free to leave them below, in the comments section. And the third thing is I try to go through as many different solution methods as possible, including using Desmos. So it's possible that the time spent going through these 22 problems will be more than the 35 minutes you are typically allowed to complete them in. So just be aware that's because I'm showing multiple methods, whereas on an official exam that you're taking, you wouldn't necessarily need to do that. I mean, you might want to do, two methods on some problems just to check your answer, but you would need to go through like 3 or 4 different methods, like I'm going to do on some. All right, so with all that being said, let's go ahead and get started on this brand new Digital SAT Practice Test 7. Just came out 2 days ago on February 3rd. First one, we have a bar graph here. For how many of these 15 days was there a charge of 0 kilowatts? Well, it's just asking for what's the value for this bar right here. Okay, so there are 6 days. That's it. We can move on to the next question. Here we have a scatter plot, and they want to know what the slope of this line is. So you, of course, can go do this in Desmos, and I'll show you how to do that. But I would just estimate this by noting that we have right here a nice intersection, right? At 3,7, and like right here we have another. It's like pretty much almost right on the line here at 4,9. So notice I go to the right one for my slope, and I go right one, and I go up 1, 2. Therefore, the slope of this line should be approximately 2. Correct answer is going to be D. Now, if you weren't sure of that, if you wanted to check, well, you could just go to Desmos and you basically do the same thing. Create a table, and you're going to pick 2 points. So 3, 7, and you pick another point that looks like 4, 9. Again, I'm just going to use those same points. Now you have this, notice you have this button here that will automatically calculate the regression. If you are not familiar with this or not sure how to use it, check out, it's currently video number 8 in my ultimate Desmos guide to digital SAT math. It talks about this automatic regression button that is new to Desmos as of a couple weeks ago in January 2025. So go there and check out that video to learn more about it. Anyways, we click this now. Linear regression is the default, which is what we want, so we don't have to do anything with the dropdown. And right here, notice the slope is 2. Okay, so that just confirms that we have the correct answer. Next up, number 3. Here, basically, this problem is telling you that 80% of some number is equal to 88. And so you can just set up an equation like this, and you can solve it by just doing 88 divided by 0.8. Answer comes out to 110. However, you can also, of course, go straight to Desmos, and you can type in 80% of x, that's what we're solving for, equals 88. Now, I don't see anything on the screen. Well, that's because I have to zoom out a little bit. There's my vertical line at 110. That tells me the solution. So again, with these percentage problems, you can literally just type it straight into Desmos, and it'll give you the answer. All right, next up, we have a table of values here, and they want to know which function is equivalent to this. So, of course, you can do this one in Desmos. I will show you how to do that in a little bit. First thing I would notice, take this 0.01, okay? If you plug in 0 for x, notice in these first two, it's going to be 25 to the 0 is 1, but then there's a negative sign, so it's going to give you -1. Same thing for this one. So 0, 1 is not on these graphs, okay? It is on each of these, so then the question becomes, which one is it? Well, if you notice, these values are getting smaller as the x increases, so that basically that tells me it has to be D, because in C, like if you plug in 1 here for x, it's going to be 25, but here it's not 25 as the y. If you plug in 1 for x, it's 1/25. So D is the correct answer. But again, we could, of course, go to Desmos. You could graph all of them and you could look at the points, or um, you could also, let's see, I guess I would probably recommend doing it this way. So if you notice, if you graph, yeah, the first two here, right? Here's what these graph looks like. And if you just graph, like some of the points, let's just zoom in and label it here. Like it's obviously not on either of those. You know what I mean? So those are wrong. And then here's 25 to the x. Okay, that one's there. And then here is 1/25 to the x. Okay, so let's get rid of these. We know these are wrong. And now you could just change the point and you could put 1 and then 1/25. Okay, you can see this one is on the black one. It's not on the purple one. Therefore, that has to be the correct answer, letter D. All right, here's another problem they like to do where they give you an equation, they don't ask for x, they ask for some other expression. So quickest, easiest way is to just notice multiply both sides by 9, and you get 72x equals 54. Correct answer is C. However, if you don't recognize that, totally fine. Just divide and get x equals 6/8. And then you just have to take that value and multiply it by 72. You could go to Desmos and do this. I can do this again also by like multiplying fractions. 6 times 9, 54. We get the same exact answer for whichever method that you choose. Next up, we have simplification of a fraction with some variables in it. So if you know the rules of exponents, by the way, I'm going to rewrite this just because the exponents are really, really small to see on the screen. Okay, so here, rules of exponents says we subtract. So 15 minus 5 is 10. So we're going to have h to the 10th on top. Notice right away that means this is wrong, this is wrong. 7 minus 21 is negative 14. So if you put it on the top, it would be negative 14, but most likely you would just flip it to the bottom and make the exponent positive. So just get rid of this. That's what I wanted to do. Correct answer for this one is going to be letter A. Now, here's how you could do this in Desmos. Just delete all that. You type the original expression. And then what we're gonna do is we're gonna add sliders for H and Q. Just probably not gonna set them each equal to 1. Just set them to whatever, random numbers. Then you go through the answer choices. Okay, notice this one matches. So I already know that this is the correct answer and this just confirms it, but just to show you the others are wrong, if you change this to answer choice B, okay, these two values are not the same, so this is not correct. If you now look at answer choice C, okay, that's a gigantic number. That's obviously not correct. And then you could change this to 3. Okay, again, this doesn't match the original value. That's how you could match these equivalent expressions in Desmos as well. Next up, we have a basic statistics margin of error type question here. So basically what's happening is the mean is 23.1 pounds. And then you have the margin of error of 0.19. So the margin of error is basically like how much you add and subtract from the mean value to get a range of where the plausible estimates for the mean actually are. So if you add and subtract, the two values you're going to get here are going to be 22.91 and 23.29. So we expect the mean to be between those two values. So it doesn't mean it has to be, but we expect it to be. So C and D are obviously wrong. Those don't make any sense. And we're looking for A, the one that has the mean values between these numbers, not B, which has it less than the small end and more than the high end. So the correct answer to this problem is just letter A. Next up, we have an equation to solve. Uh, this one, let me see how I did this one. I believe, yeah, the way that I actually did this is I cleared the fractions first just because I don't want to bother dealing with like thirds and halves and all that stuff. So I just multiplied everything by 6 and I got negative 48. And then 6, this basically became 2x plus 6, and this became minus 3x plus 6. Now, you can technically combine these at this point and you could make it negative x plus 6, but whatever. I didn't do that. I'll just show the full work if you just distributed the numbers out. It should be negative 48. And we get negative x minus 6 equals negative 48. Negative x equals negative 42. X equals 42. So the correct answer for this question is 42. But again, you do not need to do all this work by hand because you have Desmos. You could type the whole thing in equal to each other, or you could, again, use the method that I like to use, which is y equals left side, y equals right side. But since we know there's a solution to this, I'll just type the whole thing. Notice I don't see a line yet. Oh, there it is. 42, that's my answer. Again, it can be solved in Desmos in under 20 seconds. All right, next up we have question number 9. Here you have two functions and you're told what they equal when you multiply them. So I'm going to go ahead. I will do all the work out for this by hand, but again, it's going to be so much quicker and easier to solve this in Desmos. So if you go to multiply these two together, basically we're going to do FOIL, and you're going to get 9x to the fourth. Excuse me. Let's see, the outers are going to be minus 27x cubed. The inners are going to be plus 9bx cubed. And then the last two terms, it's minus 27bx squared. Okay, and now this is equal to 9x to the fourth minus 26x cubed minus 3x squared. So there's multiple ways like you could set these terms equivalent to find the b. I think the quickest, easiest way is to just set these coefficients equal, in that negative 3 has to equal negative 27b. So divide by negative 27. B is equal to 1/9. Correct answer for this problem is just going to be letter C. However, again, you do not need to do all that work. You can do this entirely in Desmos. So what we do first is we set, first I type the first function. Don't worry about B yet. We'll do that in a second. Then I type the second function. Then I have the product of the two functions. Okay, and then lastly, I type what the product of the two functions is given to equal. Let me just go back to a default view. Okay, I'm going to take this off. I don't need this. Now I can add the slider for B, and what I'm going to choose are the answer choices. So I can get rid of this. I can get rid of this. I don't care about those. This is what I'm looking for is f of x times g of x, which is the purple, equivalent to this 9x to the fourth expression when b is equal to negative 26. In other words, are the purple and black equivalent? Do they overlap? Okay, the answer is no, so I move on to B. Again, are the purple and black equivalent? Do they overlap completely? No. Now I move on to C. Notice here they are equivalent. If I deselect this, I see the purple underneath it. If I do this, nothing changes on the graph. Okay, so this just proves that they're equivalent, and you could try 9 and just show that, yeah, they're not equivalent for that one either. So that's how you could do the entire problem in Desmos. Next up, question number 10. Here we have a line going through the origin, and it's parallel to this equation. Notice slope of this line is 18, so the slope of our line is also 18. And we also know its b value is 0 because right here it tells us it goes through the origin. So this line is just going to be y equals 18x. And basically we want to know when x is 4, what's the y coordinate? So you could just go, well, 18 times 4, it's just going to be 72. So the correct answer for this one, D, is just equal to 72. Now, again, of course, you could do this entire problem in Desmos. Get rid of this whole thing. So what I would do is I would put a table. You just need the point 0, 0. You can do linear regression. And we're going to type the slope in here because we know that it is 18. So now we have the equation of the line, and we want to know when x is 4, what is the thing? So I would just type x equals 4, and now I'm just going to look for the intersection point. Okay, what is my y-coordinate? 72. Correct answer. Again, that's how you could do the entire problem in Desmos. All right, next up, number 11. Here we have a function. Okay, I'm going to show the Desmos solution to this because I would recommend everyone just do this. It is so much quicker and easier just to do this, and then I'll show you how you would actually do it by hand. Okay, I don't see the graph anywhere. Where is it? Oh, it's way over here. Okay. For what value of x does it reach its minimum? So let's see. 45. That's the answer. That's it. It's letter B. We can move on to the next problem. However, like I said, I will show you how to do this by hand. Basically, what you need to recognize if you're going to do this by hand is that this graph will have an x-intercept at 44, and it will have another x-intercept at 46, because if you set each of these equal to 0 and solve it, then you're going to get those values. Basically, this is in intercept form. It's x minus p times x minus q. The vertex is symmetric with respect to the intercepts, or in other words, the h value, the x-coordinate of the vertex, is equal to the average of the two intercepts. So you just add these, you divide by 2, that's my h, that's my x-coordinate of my vertex, and it's just 45. So that's how you could do it by hand. Next up, we have question number 12, a triangle problem. So you have a right triangle. Maybe it looks something like this. And I labeled with y here and x down here. The reason is because I think it's a little easier to understand if you do it this way. P is on xz, so point P is right here. And Q is on YZ. So here's point Q. And now if I draw this line, PQ, it's parallel to XY. So this ends up being parallel, okay, to this. XZY, so at the top here, we have 63. What is the measure of XPQ? All right, so we're looking for this angle right here. That's what we want to report as our answer. So this one's actually not that difficult. If you look at the overall large right triangle, we're going to see that you have a right angle, a 63-degree angle, and then an unknown angle down here. Okay, so the 63 and this unknown angle together obviously have to add up to 90 degrees. So that means this angle is just going to be 27 degrees. Basically just 90 minus 63. All right, so now what we can do is you can basically notice that this is 27. Then the angle we're looking for is basically a same side interior angle with it, angle XPQ. So basically XPQ plus the 27 has to add up to 180. So it's just 180 minus 27. Therefore, the measure of this angle is just going to be 153 degrees. You could also notice and said too that like if this is 27, then this angle is 27 because they're corresponding angles formed by two parallel lines. And then just do 180 minus 27 because these two angles form a linear pair, form a straight line, so they're supplementary. But in any case, the answer for this angle is 153 degrees. All right, next up, you have the consecutive odd integer problem. So these four integers are going to be x, x plus 2, x plus 4, and x plus 6. The reason that they're plus 2, plus 4, and plus 6 is because odd integers will be separated by 2 each time. Think 1, 3, 5, 7, right? You have to add 2 to get from one to the next. All right, so now we know that the product of 12 and the fourth odd integer, which is this one, is at most. So that means it's going to be less than or equal to, because there's basically like an upper limit that it has to be less than for it is at most. And then sum of the first and third. So that's the first and the third, and also 26 less than that. So x plus 4, that's the sum of the first and the third, and then it's at most 26 less than that. So that's why we need the minus 26 at the end. So now we can just go through and look at the answers and see which one matches. Okay, obviously these are wrong. These are not multiplying 12 and the fourth integer. We're down to these two, and we can see B is clearly wrong because it has the 26 in front. It's subtracting the two integers, right? So this one's obviously wrong. So the correct answer for this one is just going to be letter A. Next up, we have question 14. So here is a fairly tricky problem. You want to find basically the value of g over k. So there's actually two ways you could do this. I'll show both methods. The first way I would do is I would multiply everything here by 35, just so I'm only working with whole numbers. And so that gives me 14x plus 5 goes into 35 7 times. So 7 times 7, 49. And then over here, it just becomes 10. If you can't do that fraction multiplication in your head, just go do it in Desmos. Okay, that's totally fine. And then we have gx plus ky equals 5 halves. Now, actually, to get rid of the fractions, I also multiplied the second one by 2, and I'll explain why in a second. So we have a 2, 2, and then on the right side, we actually just have a 5. All right, so now what you're looking for is basically for this system to have an infinite number of solutions. The multiples or the multiplier between the x and the y and the number terms are all the same. Meaning to go from the bottom to the top, for example, you have to multiply by the same number. So notice on the right side here, we already know the number is 2. So what that tells me is here, the coefficient, which is 2k, multiplied by 2 has to equal 49. So 4k equals 49, or k equals 49 over 4. Same thing's going to be true here. 2g multiplied by 2 has to equal 14. 4g equals 14, g equals 14 over 4. So now what's the value of g over k? It's 14 over 4 divided by 49 over 4. The 4's cancel out. Again, this fraction simplification, you could do this all in Desmos. You get 14 over 49, or if you reduce it, it becomes 2 over 7. So correct answers, 14 over 49 is fine, 2 over 7 is fine, the decimal equivalent, 0.2857 is fine, or you could technically do 0.285 or 0.286 if you wanted more acceptable answers. So let's go ahead and type that in now. And I'll also mention, okay, so an alternate approach that you could take to do this is to notice, okay, if you take the original equations here, right? Just get the screen cleared out. Okay, g over k is going to have to equal, since this is infinite solutions, it really means these are the same line. So the ratio of g over k, in other words, the ratio of the x coefficient to the y coefficient, has to be equal to the same things in the other line. So it has to be equal to 2/5 over 7/5. So cancel the 5's out, and g over k just becomes 2 over 7. So this is obviously a much simpler, much easier way to do it, but I don't think it's as intuitive or as obvious that most people would realize or figure out. But in a problem like this, again, g over k, ratio of x coefficient to y coefficient, has to be the same for both lines because it is infinite solutions. All right, next up we have question number 15. Here we have a table of values. We know the lines. Sorry, what we know is basically this s. We have these x coordinates which have a basically a constant in them of s. And we want to know which equation of these lines matches this, right? So what you could start doing is you could say, okay, I'm going to calculate the slope between 2 points. So I'm going to do y2 minus y1, and then on the bottom s minus negative s. So I get negative 6 over 2s, or negative 3 over s. Okay, so that's my slope. And then what you could do is you could go through and you could look at all these equations and you could say, what is the slope of them? Now, I'm just going to use the shortcut formula for when a line's in standard form. It's negative a over b. So for this one, that's going to be negative s over 3. That does not match. That's wrong. This one's going to be negative 3 over s. Keep it. This one's going to be negative 3 over s. Keep it. This one's going to be negative s over 3, eliminate it. Okay, so right off the bat, just from the slopes, we're down to um, two possible answers so far. So now the question becomes, how can we choose between, um, B and C? In other words, how do we know which of these is correct and which is not? So what you could now do, and you actually could have done this from the start, but I prefer to use the slope to just eliminate two of the answer choices right away. Just pick one of the points and plug it in and see which one matches. So for example, take B, 3 times S plus S times the y value 15 equals 18S. On the left side, I get 3S plus, careful, it's really annoying. These are S's and the other things are numbers. So I get 3S plus 15S, I get 18S equals 18S. So that checks, that matches. Notice if you do it for C, you will get 18S equals 18. May be true, possibly true, depending on what the value of S is, but not necessarily true. Not necessarily true, not true for every value of S. And we want this equation to be true for every value of S, which is a constant. So the correct answer is going to be letter B. So that's how you could go through and use process of elimination to basically confirm it. Now, what you could also do is go to Desmos. All right, we're going to put in this table of values. Okay, I'm going to add a slider for S. Okay, I'll just move it here, whatever. Now I am going to do a linear regression. The reason I do this is I just need to get the graph of the line that matches matches this table. What I will do next is I will graph the various answer choices and I will see which one overlaps entirely the graph I have from the linear regression. Okay, so I just did A. A is wrong. Now, actually, no, this should be S. Sorry. There. That's A. That does not overlap. That's not the answer. Now I can go to D because I can just delete this. Okay. That doesn't match. D is not the answer. So now I'm down to. Wait, this is, sorry, this is SY. There we go. This is B. This overlaps entirely. Notice I take this off. I see the line underneath it. That's the regression from the points. And notice, even as I move the S value, both lines move together. That confirms that B is correct, okay? Because both my regression line and my answer choice are still overlapping, even if I move S around. And of course, if you check C right here, notice they do not overlap. Now, if you choose s equals 1, they do overlap, but for any other value, they don't. So you can clearly see here that C is wrong. So that's what I was saying before about the equation needs to be true for every value of S, not just some particular values. But again, answer for this one is B. Next up, we have question number 16. So for this one, basically you have a system of equations and the system has exactly one distinct real solution. They want to know what the value of k is. So first I'll show you how you can do it by hand. And then after that, I will show you how you could go ahead and do it in Desmos. All right, so first thing, if you're going to do this by hand, the way that I did it was I went ahead and I got both these equal to y. So I got y equals x plus 26 minus k, y equals x squared minus 5x plus k. Then I set them equal to each other, x squared minus 5x plus k equals x plus 26 minus k. All right, to get each of these equal to get basically one real solution, I'm going to set this equal to 0 first. So I'm going to move everything over to the left. That's going to give me x squared minus 6x. And then, sorry, not minus 6x. Yes, minus 6x. And then we have, just make sure I have this right, minus 26 and then plus 2k. K equals 0. Now, at this point, there are technically two ways you could do this. So one way is, if you're familiar with completing the square, you would notice here that this is going to complete the square as x squared minus 6x plus 9. Because b is negative 6, you take half of b, which is negative 6 divided by 2, which is negative 3. You square it, you get 9. So that means for this to have exactly one real solution, this whole thing right here is going to equal 9. All right, so in other words, negative 26 plus 2k equals 9. 2k equals negative 35. K equals negative 35 over 2. You could put that in as your answer, or you could also put in 17.5. All right, so I'll just go ahead and type that in now. However, uh, if you did not recognize that, that's fine. What you would then probably do is you would say, okay, I need the discriminant of this quadratic equation to equal 0. That's what's going to give me one real solution. So the discriminant is just going to be b squared, which is, well, it's going to be plus 36. It's technically negative 6 squared, minus 4 times a times c. All right. So it's 36 minus 4. I'm not going to distribute this just to like save a little work. And then what happens if you subtract 36? You get negative 4 in front of this parenthesis. Divide by negative 4. Negative 26 plus 2k equals 9. Notice this is the exact same equation that I had before. So if you go ahead and solve it out again, it's 2k equals negative 35, k equals negative 17.5. All right, here, write it up here. It's hidden behind me. Okay, so those are kind of two different methods. I mean, still kind of similar how you could do it by hand. Now, if you go to the calculator, so let me just first here clear off all this. Okay, what I would probably do is I would, again, get y equals for both of these equations. And then essentially you're going to move the slider. So notice here you're looking for one intersection. So like you can see there's 17.3, there's still two intersections, so it's got to be above that. 0.4, 0.6. So now if you do 17.5, notice there's no actual clickable point here because it's a tangent line. But you can basically zoom in and see that it's like just, touching at this, basically at this one value here. Essentially it's 3 comma 11.5. Or you could also have essentially gotten the other way you could do this, at least using Desmos just to save some of the time, is you could have gotten the the x squared minus 6x minus 26 plus 2k. And this is a method you could use to determine this definitively. So here you still do the first step where you set the equations equal to each other and you get everything equal to 0. But instead of solving for k by using either the discriminant or by, completing the square and making the c term equal to 9 and solving, you can instead, so like say you start here k equals 1, basically now with this quadratic to have one real solution, you needed to just touch the x-axis. So you can move the slider and now you can know for sure definitively when there is one real solution exactly, because you will see exactly one clickable point on the x-axis. Okay, and you could adjust the slider obviously as needed for the problem. If it turned out to be 17.4 or 17.3 or 17.45 or whatever, you can like set the parameters here on the slider to like zoom in and get more decimal places. But if you do this approach to solve for k instead of leaving out all the work in the second half of the problem, this way you can actually determine, yes, definitively, this is the k value for one real solution right here, because this quadratic is now just touching the x-axis at only one point, i.e. there's only one x-intercept. All right, next up we have question 17. Be honest, I have no idea why this problem is number 17 in this module. This is honestly probably the easiest question on the entire module. This also, I think, appears on module 2A. Uh, so this is ridiculously easy problem where you just plug in, you know, 4 for x, and you just get 1/2 times 10, which is 5. And that's it. And I mean, if you want to, you can go to Desmos, but I don't think on this it would save much time to either do it this way or to do f of x equals and then just do f of 4. Okay, so regardless, I have no idea why this problem is so late on this, you know, on this module. All right, next up, question number 18. Here we have a word problem. And the thing that's just a little bit tricky about this one is, so you have this rectangle, right? And we know its length is x, but they tell us that the length is 24 inches longer than the width. An alternate way to phrase that is that the width is 24 inches shorter than or less than the length. Therefore, the width here has to be x minus 24. Again, don't ignore my picture, which shows the opposite. Figure not drawn to scale. So again here, if the length is x, which that's what they tell you, then the width has to be x minus 24, because the length has to be 24 inches longer than it. And that checks out. If you take this width and you add 24 to it, you get just x, which is what the length is equal to. So now the area of a rectangle is just length times width. So it's x times x minus 24, and we set it equal to 2661. So we get x squared minus 24x minus 2661 equals 0. Excuse me. And that should be answer choice A. Next up, here we have a question involving a cone, basically a 3D figure, and we've got information about its volume and its area of its base, and we want to find out its slant height. So this is a fairly complicated problem. There were reports, of a bunch of these on the official tests that were given all throughout 2024, but there was nothing anywhere close to this on any Bluebook practice test. But now we finally do have one. Okay, so let's try to get a picture of the cone here. All right, we know its volume is 71,148 pi. We also know the formula for volume, 1/3 pi r squared h. If you forget that or don't know that, go to the reference sheet right here. Volume of a cone. All right. So now, with that being said, we don't know its radius or we don't know its height, so we can't really use, we can't really do anything with it quite yet. However, we know the area of the base, which is a circle here, is 5929 pi. So we also know that the excuse me, the area of a circle is pi r squared. So if we set that equal to 5929 pi, then the pi's will cancel out. You take the square root of both sides, you're going to get a radius of 77. Okay, let me just go to the calculator, delete this all out of here. All right, yep, 77. That is the value for our radius. And I'll just store that in. Not sure why it wasn't letting me type that. But anyways, store that in as R, capital R, just for right now. All right, now we can use that to find the height. Now, I will mention one thing just after this, just after I calculate this height. Let me mention one more thing related to this. So we got 71,148 pi equals 1/3 pi 77 squared times the height. So now what we're going to do to solve for the height is you're going to have to basically multiply this by 3. The pi's will cancel out. And then you're going to divide by 77 squared. All right, that is going to give us, when we plug it in, our height value. So let's go back to the calculator. It's over here so we can see it a little bit better. Our height is going to equal 3 times 71148 divided by r squared. Okay, so our height is just equal to 36. So now we have every piece of information that we need to calculate the slant height. Because, oh, actually, sorry, before I begin, the one thing I want to mention, okay, technically, you can cut out basically a couple steps here. If you recognize that really the formula for volume of a cone it's really 1/3 area of base times height. In other words, this pi r squared, that's the area of a circle, but the circle is the base. So if you recognize that, you can save some steps because you can just take this whole thing and you can just plug it in to this right here. Meaning you don't need to calculate the radius initially in order to get the height. However, you do need the radius for the next step. So it's like it saves you a little time initially, but then you still have to end up calculating your radius anyway. So I just went ahead and did that first, since we will need it in the end. All right, so I just wanted to mention that, get that out of the way. Now, what's going on here is basically you have your perpendicular down here. This is your height. Then you have this over here, which is your radius. And then this hypotenuse of this right triangle, that's your slant height. That's on like the surface of the cone. So we're just going to use Pythagorean theorem. It's just r squared plus h squared equals l squared. All right. So an L is just our slant height. So now I'm just going to plug in those values and we'll go back to the calculator. Also, a little bit of a tip, and this is something you would know if you watched my um, Ultimate Desmos Guide to Digital SAT Math. Whenever you want to do something with Pythagorean theorem, just type in, the a squared plus b squared equals c squared, except we're going to do it using regression, and we're going to use a tilde. So I can just type r squared plus h squared. That's why that's part of the reason why I defined them earlier in the problem. And then the tilde, and then we'll put L squared for the slant height. So that's it. There's our slant height. That just basically solved that Pythagorean theorem problem instead of having to do it all out by hand and adding, the numbers and square rooting both sides. So the slant height for this problem, for this cone, is just going to be, 85. So it's 77, 36, 77, 85. Right triangle. All right, next up, we have question number 20. So this is actually a repeat from a problem it's not the same exact problem, but it's very, very similar to ones that appeared on one of the linear um, practice tests. And I'm not gonna bother showing you the solution, which is like similar to the way the College Board solution is. I'm not gonna bother showing you, you know, you could technically pick values for R and you could plug them in, and then you could get a point here, and you could see, okay, is that point on the line? I mean, these are both basically the same line. It's not, it's just infinite solutions, so you really have to check it in one. I'm not going to bother doing that because honestly, it is so quick and so easy to just go straight to Desmos and solve this entire thing in here. So again, you only have to graph one of the lines. If you don't believe me, you can just see the second one's multiplied by 4. Every term has a multiple of 4, therefore it's infinite solutions, it's the same line. All right, so now all I'm going to do is I'm going to type in my points. And then I'm going to put a slider for R. Also going to label the points. So notice when I move the slider, is this one always on the line? No, it is not. Therefore, it will not be the correct answer. This is B. It's not even on the line. Make sure I typed it correctly. It's not even on the line right now. So therefore, it is not, B is not the right answer. All right, well, what about C? I don't even see it on the screen here. Oh, it's way up here. Is C on this line? Absolutely not, because it needs to be on here for every real number of R. So no matter where I move the slider, we need to expect to see the point on the line. All right, well, what about D now? No, I meant this should be, sorry, down here. There we go. Okay, so first, let's get rid of this. Let's get rid of this. Let's get rid of this. Notice D stays on the line the entire time, no matter where I move R. So D is the correct answer. I would only recommend solving those problems using this method in Desmos. I wouldn't even waste time on the other methods personally. But if you want to, whatever, you can go look up the College Board, explanation and basically just, see how they did it. All right, next up, number 21. This again is another repeat type question of ones that we've seen before on like previous, I think previous Bluebook tests. It's this whole idea that like the first day for something costs some amount, and then every day after that it costs a different amount, and they want you to find the expression for how much it costs, for the total number of days. So here's the thing: the amount, additional amount, the amount for each additional day, okay, that is going to be the slope of your line. So like right away, these are wrong. All right. And then we're down to these two. B is always the choice. The answer choice that features the two numbers that you're given, like that's the trick. That is never the answer. It is always the other one that has this as its slope, but then a different number as the y-intercept. So here's the reason why. If you set this up, it's $52 for day one, and then it's $26 for all the remaining days. But the total number of remaining days, if you rent it for a total of D days, it would be D minus 1 days that are charged 26. In other words, this is like day 1, and this is, day 2 through D, or whatever you want to think of it, day 2 through 10. So 1 day is 52, but then there are 9 days that would be the 26. So if you take this and just distribute it and then simplify it, notice you get 26D plus 26. Okay, so the correct answer is A here. But I'll show you another alternate method you could use is picking numbers. Let's see, what did I pick? I said let D equal 3. So you rent it for 3 days. That should be a total cost of 52 plus 26 plus 26, which comes out to $104. So now you just go to Desmos, or I mean, I guess you could do it in your head if you want to. Clear all this stuff out. And you see, okay, when I plug in, actually I do it of X. Okay, when I plug in 3, do I get 104? So for A, the answer is yes. Now, when I check B, notice the answer is 130, so it is no. When I check C, I get 130 again, not 104, so the answer is no. And then lastly, when I check D, I get 234. That is not 104. So this is just an alternate way you could do it. This is basically back solving. You pick a number, you plug that number into the answer choices, you see which one matches the value that you expect to get based on the information given in the problem, which in this case is cost of $104, and then you see which answer choice gives you that same value, and that has to be your answer. All right, last question. Here we have a unit conversion question. So we are starting off with 7.3 meters per second squared. All right, and we're converting this to miles per minute squared. So we have to first convert the meters to miles by using the conversion factor that they give us. So we're going to put meters on the bottom and we're going to put miles on top because we want to get miles per minute as our final answer. So meters, excuse me, will cancel out. Now we have to convert seconds squared to minutes squared. So you should already know 60 seconds, 1 minute. 60 seconds goes on top, 1 minute goes on bottom. But here's the problem. This is seconds squared in the denominator. So you need to multiply by this scale factor twice, or you need to square it. So you put a parentheses around it and square it, or you multiply by the same scale factor twice, meaning you write it a second time. All right, and that's what you have to do because it's seconds squared to minutes squared. It's the same thing as if you were converting between area units, feet squared to meters squared. So now seconds squared cancels out, and we're going to get our answer here. Looks like it should be 7.3 times 60 times 60 all over 1609. So I get 16.333126, blah, blah, blah. So which of these is closest to it? Well, it's obviously B, 16.3. All right, so that was brand new practice test 7, the math part, module 2B, the harder of the 2-second modules. I hope you enjoyed this video. If you did, please give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, if you haven't done so already yet, please check out the solutions to the same practice test, but Module 1, and also the solutions to this, again, same practice test, but Module 2A, the easier of the 2-second modules, once that is posted. Otherwise, if you have any questions or comments or feedback, please feel free to leave them, in the comments below. And in the meantime, check out my other videos with, reported questions from 2024 tests. Check out the Ultimate Desmos Guide to Digital SAT Math if you want to brush up on your Desmos skills. Or be on the lookout for the solutions to practice tests 8 and 9 and 10 as I eventually work through those.